Hello, voice test 111. Hello, voice test 111. Okay, now it says it's live. Okay. Semendek Aikarana, I think. Yeah, so let's do this. See, close that. Okay, everything is working correctly now. No, what? Um, yeah, so, okay. ያ አራት ቀን ብቻ ነው የቀረን ካሁን በኋላ ዳይ 9 ዳይ 10 ዳይ 11 ዳይ 12 አራት ቀኖች አጌስ የዛሬውን ከጨረስን በኋላ 3 ቀን ነው የሚቀረን። የትላንትናውን ደግሞ አይ ክሎዝ ዘ ስትሪም ዊዛውት ኢቨን የትላንትናው ስትሪም ላይ ያልጨረስኩትም ነበር። ሶ ይሄንን ሶሉሽን አይ አስክድ ፒፕል ቱ ሴንድ ሚ ሳም ሶሉሽንስ ኤንድ ሰምዋን ሴንድ ሚ ዲስ ከዛ ቤዚክሊ ይሄንን ኮድ ወደ ታይፕስክሪፕት ላይን ባይ ላይን ነው ኮንቨርት ያደረኩት and then how it works is it has this union find thing, but the first thing you need to do is actually you need to like you need to find the distance between each coordinate and put them in a sorted list. So that's what this is doing. So it's not like so A to B, the distance between A to B is equal to the distance between B to A. So it does that check. So you create that distances list, and then you use this union find data structure, and it has this union field. So I think what it's doing is you just keep on passing the first index and the last index. So these are the positions of the coordinates in the list we generated, and then basically instead of concatenating them or keeping them in a list, it just keeps on incrementing the size for each one, and then you finally sort the sizes, and then you get the largest 3 ones. So if we were asked to like keep the values, we would be pushing into an like a coordinates list here, but instead we're just incrementing the counter at the size of the what is it? I don't know, the connection at this point. And then we finally just sort the sizes and then get the first 3 ones and multiply them together. I've never actually heard of this. I actually tried to find some information about it, but I didn't see anything good. Yeah, I was looking at the Wikipedia page and stuff like that. Basically, I think it's meant for joining multiple sets together to be represented as one set. I think that's the idea behind it. Yeah. But yeah, I like ካሁን በኋላ እያስፈራኝ like I think የመጨረሻ ቀኖች ላይ እየመጡ ሲሆን ከዚህ በፊት ያለው even if you didn't know any like DSA stuff like እኔ አሁን some like እንደዚህ data structures ምናምን I haven't memorized a lot of them. I know about the common ones, but I don't know about like this one is very. I've never actually heard of this one before yesterday. I'm feeling like it's like ከዚህ በኋላ ያሉት ጥያቄዎች እንዳለ እንደዚህ የሆነ ዴሴ ፎከስድ እየሆኑ የሚመጡ እየመሰለኝ ነው, but we don't know. So I'm actually thinking of like I'm running out of what is it? Programming languages. So my plan is we're gonna be using Rust for the rest of the 4 days from now on. So yeah, so it was good while it lasted, but we're not gonna be doing a new language paradigm from now on. We're gonna be using Rust for all 4 of them. So let's set that up right now. So we have the 09 here, and then let's do cargo, and don't I have cargo? Rest. Wait a minute. How did we? Maybe I removed it. I accidentally removed it. Well, I think I accidentally removed it last time. Oh no. Okay, GitHub breakdowns. And let's see. Maybe I deleted it. Hopefully, it won't take us a while to download. Let me just copy this. We need this too. Wait a minute. I remember we used Rust for die 4 or something like that. And then maybe I accidentally removed it from the Flick Dynamics. I don't know what happened. Yeah, we used the Rust for die 4. Let's go into Flick Dynamics. I think maybe I accidentally removed it at some point. But hopefully, okay, yes, it didn't take us any time to start. Let's go into die 09. Cargo new part 1. Let's go into part 1. Cargo run. Let's make a directory for our inputs. Then let's move cargo run over here. Die 09 part 1 cargo run. So what are some libraries I think we're gonna be using? We're gonna be brute forcing it as usual, so we're gonna probably use Rayon, which will make our which will parallelize our iterators and stuff like that. And we're gonna use PateGraph. I think I remember using it back in 2023. It's a graph library for Rust, so if they ask us like to calculate the distance between some graphs and stuff, some like nodes and stuff, we'll just build up the graph using PateGraph, and then they have a bunch of distance functions, and yeah, so I think it will be in here, whatever kind of algorithm or thing they ask us. If it's probably graph based, it's gonna be in here, and then we might probably use itertools to have better iterators and stuff like that, like Cartesian product, combinations, permutations. So I think we'll be installing one of these 3 libraries or maybe multiple of them, but we'll see. Yeah, let me open up the Rust file here. Hello string, just do that to make sure it's working correctly. Okay, now we just have to wait. For it to open up. We can actually do this until then. We can say let input equals include star of inputs / example text. Yeah, this shouldn't compile because the file doesn't exist. It should be, so we will be able to create it here. Let me git ignore some stuff. Git ignore target. Okay. Yep. 16 seconds, 15, 14 seconds, 13 seconds. That's there. Okay, hopefully it will be an easier one. I don't know what just happened to my OBS window. What is this? Am I still streaming? It just got fully covered with the YouTube window. I guess I can't see myself then. Okay, let's read the... Okay, ooh, it's one of those things where we have 2 inputs. Okay, let's read through it. You slide down the fire pole in the corner of the playground and land in the North Pole. The North Pole based movie theater. The movie theater has a big tile floor with an interesting pattern. Elves here are redecorating the theater by switching out some of the square tiles in the big grid. They form. Some of the tiles are red. They would like to find the largest rectangle that uses red tiles. Okay, for two of these opposite corners, they even have a list of where the red tiles are located in for two of its opposite corners. Okay, they even have a list of where are located in your grid. Okay, this is showing red tiles as that and other tiles as this. The above arrangement of red tiles would look like this. So some one of them starts at 7 1, another one at 11 7, 11 1, 11. Okay, you can't choose any two red tiles as the opposite corners of your rectangles. Your goal is to find the largest rectangle possible. So the largest rectangle possible is it's like the same problem as yesterday. تلانتنا that's a problem لو the largest possible is gonna be the one with the largest distance, the combination with the largest distance between each other, right? Okay, you can choose any two red tiles as the opposite corners of your rectangle. Your goal is to find the largest rectangle possible. For example, you would make a rectangle shown as with an area of 24 between 25 and 97. Okay, or you could make a rectangle with an area of 35. Okay, you could even make a thin rectangle with an area of only 6. Okay, ultimately the largest rectangle you can make in this example has an area of 50. One way to do this is using two red tiles as opposite corner. What is the largest area? I think this is the same problem as yesterday, so let's copy over the same problem as yesterday basically, but I think so. Let's go into inputs, example.txt space design, and now we can have it. So let's do let line, let's call them nodes, and then let's do input split. It's asking us for what is the largest area of it's asking us for the area. So let's do not gonna do, let's do lines and then map over each line, and then line dot split. I guess split out is what we need. Split out and split out, a comma. So we now have an iterator of split out should be a character. The heck, this should be a character. Let me remove the inlays because they're confusing it. Okay. Oh, split out is not how that works. Okay, split once. Yeah, this is what I wanted, split once. And then this could be a flat map, and then we can collect. No, we don't have to collect, we can say, so let's map over this again, and let's take x comma y, and let's go x dot parse and y dot parse. Then this will be a wake of u32 comma u32 and then unwrap. Yes, it will infer it, so I don't have to tell it that type here. Debug nodes. Okay, this is correct. And then I'm gonna use itertools. Cargo add itertools. They have this tuple combinations. So if you give it 1 to 5 tuple combinations, it will match 1 with 2, 1 with 3, 1 with 4, 2 with 3, 2 with 4. So each one will have like but no, the distance will always be the same, right? So our distance function that we're gonna come up with, basically it's gonna return the same if you're doing it from this to this, or if you're doing it from this to that. We will absolute value it. Okay, itertools has been installed, I think. So let's go down here and say distances. Right, it's gonna be nodes dot tuple. I guess let's save this lsp restart, and let's go up there and let's say use itertools. I don't think I have to do that. It will import it by itself. Nodes dot tuple. I guess I have to do some base import. I have to do this. Okay. Just do tuple combinations of. Do I have to tell it, or will it know about it from the type? I think it will know about it from the type. So tuple combinations. Yeah, if I just start, okay, so if I just map over them and start taking an A, comma B, so let's get this, let's create a function called dist here. It's gonna take a node u32, but I guess here they're both borrowed. You can say it's gonna take this, and then B is gonna be that u32, comma u32. It's gonna return b dot 1 minus a dot 1. This is the height. If what dot 1 is gonna be, I guess let's do this, x1 and no, y2, x2, and then it's to x1 comma y1, y2 minus y1. This is the height times x2 minus x1, and then let's return a u32 here. But what I'm worried about is, I think let's do this. Let's use i32s. Instead of u32, i32, and then what we'll do is we are gonna return the absolute value, and then let's return a comma b comma dist of a comma b from here, and then let's collect that into a vec. I just want to see that our distances are being calculated correctly. Let's go cargo run. Am I doing another debug here? Let's move this debug. We don't need that anymore. Okay, so they said, what did they say? The largest one is between 2.5 and 11.1. So 2.5 and 11.1. 24, 12, 18, 20, 10, 12, 36. So 11.1 and 2.5. Okay, that's correct. So 36, we have 36 here. So we're gonna, it will make it easier for us to, let's do sort by. Let's do sort by. We don't care about that, we don't care about that, we care about the distance. Let's sort by the distance. It takes a single 3-tuple argument. Sort by. Oh, I guess sort key, that's what I wanted. Sort by key. Sort all elements into a iterator in ascending order. What is it saying? We have to do, let's look at this. A, doesn't matter much. It's gonna be a dot 2. Okay, and then cargo run. I guess sort by, we're gonna do this to make it, to have the largest be at the top. Okay, so this is the largest one. So we already have the answer, I think. Ultimately, the largest rectangle you can make in this example is the area 50. So what we're going to need to do, I guess we don't need the that was surprisingly easy. You're making me, it's like, I don't know. So solution is, you're telling me it's distance 0.2. Of course you have to do that. Why are they doing this? It's like, it can't be that simple. Input that text. Let's save this. Yeah, these numbers seem fine. They should be able to fit in an i32. I don't think we don't have a lot of numbers. So let's move inputs. Let's look at it. Yep, we have it. And let's run it. Of course, we need to switch the input to be input.text. Let's run this. Oh, trade panicked. Attempted to subtract with overflow. Oh, okay, so they didn't fit in an i32 then. Select i32, i64. I guess because we're multiplying them. And i32 to i64. they didn't fit within an I32. Let's try this out. That's not the right answer. It's code, I guess. Like it can't be that simple. No, take example.text cargo run, and then let's look at the distance. So what is it saying? So using two red tiles as opposite corners, what is the largest area of in this case, our example wasn't even correct. So these are the area, according to our calculations, it has the area 36. Okay. We did find the correct, the largest one, but maybe there's something wrong with our distances function. Distances as a structure. This it should be a borrow here. So let's try to do the maths manually ourselves. So calculator. So the largest one we know is 11 minus 2 times 1 minus 5. Oh, I know what's wrong. We don't have to, we have to do the absolute value for both of these, right? We have to not on the final one, but yeah, I think that's the mistake I made. So this is absolute value, and then this has to be absolute value, and then cargo run. Okay, still 36. This is 2,5. Okay. This is 1, 2, 3, 4, 5. It got that by doing let's move up here. This is, do we have to do the Cartesian product then? Yeah, I think maybe the distance calculation, is it different if we do 11 minus 12, and then if we do then this will be 9, so that's and then 1 minus 5 will be minus 4, but when we do absolute value on it, it will be 4, so 9 times 4, which is 36. But in their calculations, what happened was, so this is okay, maybe I'm actually confused about so y is the row, and 5 is the, y is the row, 5 is, what's 5? Which one is 2, 5? 1, 2, 3. So grid locations. No, this is 11, 1. This is the Okay. So 5 is 0, 1, 2, 3, 4, 5. So this is 2 comma 5, and then this is 11, 1. So because it's on the second row, and it's, I guess, the 11 in the 11th position. So when we do 11 minus 2, we get 9. So this should be 1, 2, 3, 4. Let's do this. Copy those. Node dot length. Oh, we got 10 instead. What? So it's like a one by one, off by one error. We have to, since we have to include the plus one. Let's remove the Cartesian product because I don't think that's what's causing the problem. To be plus one, and then plus one. Okay. Let's run it on our input now. Input. This is the same number I got earlier, I think. Same number. Oh, nice. It's nice. We got one gold star. Okay. Let's go into part 2. Oh, before we do that, let's do this. Cargo format. Reload. Seems correct. Let's add this. Commit feed implement. Die9 part 1. What? What? I got too excited. Let me just do this. Come on. I'm gonna turn off the stream and maybe see what I'm typing. Did my keyboard? Okay. Okay, so now we've just implemented part 1. Let's close this. No, let's close this. Let's do dots, and then copy -pr to part 2, and then it's going to part 2. There is something we need to rename. Cargo tunnel. This is part 2 now. Let's run cargo r, and let's open up the file of this. Okay, so let's read day 2 part 2. I mean day 9 part 2. Okay, the else, just remember, I can only switch out the tiles that are red or green. So your rectangle can only include red or green tiles. In your list, every red tile is connected to the red tile before and after it by a straight line of green tiles. Okay, the list wraps, so the first red tile is also connected to the last red tile. Tiles that are adjacent in your list will always be will always be on either the same row or the same column. Okay, using the same example as above, the tiles marked above will be green. Okay, so it's describing one chain of connected connected distances. In addition, all of the tiles inside this loop of red and are also green. So in this example, these are the green tiles. Okay, the remaining tiles are never red or green. The rectangle you choose still must have red tiles in its opposite corners, but any other tiles it includes must now be red or green. This significantly limits your options. For example, you could make a rectangle out of the red and green tiles with an area of 15. Okay, you could make a thin rectangle there. Okay, the largest rectangle you can make in this example using only red and green tiles has area 24 and is between this and that. Using two red tiles as opposite corners, what is the largest area of any rectangle you can make between? You can make using only red and green tiles. Okay, so okay, let's. How would we do the filtering of the bounds checking, right? How would we do the bounds checking? Or could we have this be a property of our? Do we have to implement bounds checking for this, or can we have it be part of our distance calculations? Maybe we can filter out the impossibilities by doing something like if they are not contained within something. So we would I think I'm thinking of coming up with a filter we can apply here, right? A filter, and we would calculate the bounds here and determine if the current points we're looking at are within the bounds. So the bounds is going to be, so we have the list of nodes. So every red tile is connected to the red tiles before and after it by a straight line. So it's like boom, 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 boom. Okay. That is true. So we can get like a corners function. So the corners, so we already have the corners. So this is the corners. These are the corners. So from the corners, we need to determine if we can't do. So I think the largest one previously was this one, or I guess it was this one, but it will contain all of these like non-allowed tiles. So using the same that would be green. Okay. In addition, all of the tiles inside of this loop of red and green tiles are also green. So inside of this is also green. The remaining tiles are never red or green. The rectangles you choose still must have red tiles in opposite corners, but any other tiles it includes must now be red or green. This significantly limits your options. Okay, for example, you could make a rectangle out of red and green tiles with an area of 15 between 17 and 4. I think this is እስክሪብቶ የሚያስፈልግበት ሰዓት ደርሰናል. So I'm gonna try writing stuff down. Let me go back here. Yeah, so how can we come up with this list? So we have a comma b comma. So we have numbers like this, d comma a. These form some points on a plane. We want to know if a point or all points within. So what we want to do is we want to come up with like something that's like, we can do stuff like this. So what we need to do is, we would, after doing the distances, we will do filter a comma b, and then so we would say is contained in, and then we would say, I think this is what I'm thinking, this is where my mind is at now. So we would say is contained in, we would give it the a comma b, and we will also give it the nodes as a slice. So we would need to create something like this. So it will be like this, but it will have a nodes, or I guess let's call this corners to make it easier to understand. And this will be a slice of I32 on I64, comma I64. And then this is contained in, so we want to make sure that these 2 points, the area that would be generated by these 2 points, or the area between these 2 points, is contained within these corners, is contained within the bounds of these corners. So how do we do that? We would do, I guess we would need to iterate over each corner. So for corner in corners somehow, thinking that's the case, but this will make our algorithm way slower if we're going to be iterating for, like, it will be like, yeah, too much. So for corner in corners, it's something like making sure something exists. So if we're trying to, for example, let's look at this. I got it. What we need to do is make sure all of the corners, so let's do top left would be something, right? Let's do top right will be something, and bottom left would be something, and let bottom right will be, I don't know, let's do 0. But what we need to do, I think, is make sure all of these values should be corners, should be other corners, right? We're not just considering. So if we look at the largest one they found, so this is a corner, and this is also a corner, and this is a corner, but okay, so at least, so there must be at least 3 corners. Is that the requirement I'm saying? Is there any way in which, or, but this one is contained, but it's not actually a corner. It's not actually a corner. How do we check if a point is inside this grid? But what, like, the basic idea is, I think I was gonna just check the corners, because at least I think, but I guess I think it will also, so one of the corners is inside. There could be like you could take a combination, like, for example, this and this, so they have like 1 2 3 3 points in there, but the fourth one is not in there. So at least all of the 4 points of this would need to be in the in the in the grid. Come on. I think that's it basically, but that doesn't work. I was gonna say if these need to be specifically corners, but seems like they don't they don't have to be corners. We can create a list of the perimeter, and make sure that it's there at least exists one corner where there at least exists one corner. No, I guess that will also help make us go into these scenarios. There is at least one corner that has I'm not sure, but I think there is an algorithm for this. Okay, so algorithm to check if a point is in a grid defined by a list of corners. I think this is it. Iterate through the rest of the corner to find the true min max. Let's implement this pseudocode. Let's copy that. Let's comment it out, and let's say is point in, and the point will be something like this: x comma y, and it will be a reference to i64 comma i64, and then we'll have our corners, just that, and it will return a boolean, a bool, and then we can say so min x, get mutable min x equals x max x equals x. Let's do the same for, I guess, the y. That's not gonna work. y, and then iterate over each corner for for x comma y in corners. If x is less than min x, I guess. What are we doing? So it's doing meaning it's like, so min x is equals to x dot min, or this is correct, right? So if it was, let's say, to 2 here, let's say, so in this case, if it's less than the minimum, it's setting the minimum to, if the current corner is less than the minimum we defined, it's setting it to be there. But in this case, if this will take either the minimum or one of them. So if min x was already less than it, it will. So I think this is what we want. And then max x will be I guess x dot max x, and then same for y's, min y. This is what it's trying to do. And then finally, check if the point coordinate falls within the established range. So if x is greater than or equal to min x and x is less than or equal to max x and y is greater than or equal to min y and y is less than or equal to max y. If that's the case, we return true. I guess this is just return that. So I think we can test this by doing something like, let's do this. Let's make sure that is pointing function is correct. Let's do this. Let's comment this out for now. So is, let's say, debug is point in, we'll give it the corners, and let's give it 0, 0. This should return false, because according to our nodes, so this point here is not in there. 0, 0 is not there. So let's cargo run this. Yeah, I'm also done with part 1. Yeah, I'm doing part 2 now. But I don't get out. My plan is to get the list of corners. So, no, not part 1, but part 2. So my plan is to get the to create like a this is point in function. So it will take the corners and do some kind of, I don't know, like some min and max stuff to determine if like the point I'm giving you is contained within these corners. And then once I have that, I can make sure that in the new rectangle we're going to be creating, all of its corners, the top left, the bottom right, bottom left, and top right corners are all contained within that corner, and filter out only those like distances. So that's my plan, and I don't think I'm gonna be using Elixir. I think I've decided that from now on we're just gonna be using Rust for all of the all of them from now on. For the next 3 days we'll just be using Rust. So this thing is not true. This thing is not working. So is point in returned true. It should have returned false. It should have returned false. It's rectangular. If your grid is rotated, is a complex convex polygon, not just an axis aligned function, the AAB method above will fail. Oh, I get algorithm to check if a point is in a grid defined by a list of corners, uh, not AABB, I guess. The most common and efficient algorithm to check if a point is inside an arbitrary polygon is defined by a list of ordered corners is the raycasting algorithm. Oh damn you, Advent of God. What's the raycasting algorithm? Raycasting. Okay. Oh wow. There is a concept called pointing polygon. That's exactly what we want. Pointing polygon, yep. The number of intersections array passing from an yeah. Oh, but pointing polygon, that's not exactly about not array, but we want to check if um, okay, it's not giving us the algorithm in here. Point in polygon for an arbitrary polygon. Okay, so an arbitrary polygon defined by a list of corners. Should we watch another YouTube video? Should we watch a YouTube video about this? Okay. Or winding number algorithm, even ordered. If the array crosses an odd number of edges, no. We have to create an array and then what? Holy shit! What is this? Yeah, this feels too complex. I knew that it wasn't gonna work. Uh, what is this even doing? Let's check if a point is inside a polygon using raycasting algorithm, even ordered. Point x, y, tuple of point to check, polygon vertices, a list of x, y tuples representing the polygon's corners in order. It's not in order. Does it have to be in order? We don't know that it's in order. Let's go back here. Do they mention anything about that? What does it mean in order? In order of what? I mean, they're in order, I guess. 7-1 is the first one. Yeah, I guess they are ordered somehow. Yeah, they are ordered. Okay, so it first we get the point, and we get the number of vertices, and we have a boolean that says inside. It initializes with false, and then we get the first vertex. We get the first corner, and then we iterate over the number of vertices plus 1, and as we go along we modulo number of vertices, so we get the next one. So this is doing something like tuple windows, I think, right? So for example, when this is 0, this will be 0 modulo number of particles. It will just be 0, I guess. And then 1 modulo number of particles. Number of particle things. I guess when we get to number of particles, it will be 0. And it's trying to, oh, I don't know why it's doing this. It's because it has to do the loop, because it has to check the last position with the first position. That's why it came up with this algorithm. So this will make it so that when you run it with the, I guess in that case 0 modulo something is the links. So 0 modulo 10 is 0, okay, but 10 modulo 10 will be 0. So that's what it's trying to achieve. That's what it's trying to achieve. So if y is greater than that whole complex thing, and the points are not the same, and then the x intersection is that, and if it's less than the x intersection, not inside. Okay, I don't know, let's port it, I guess. Let's start porting. Let's remove that. We already did that, so let's create late num vertices. Let's do this. Copy, paste. It's this, but in our case it's not like that. It's gonna be like this, but we don't even call it polygon vertices. We call it corners. And let's add a to do here, because right on complain. So it has a late mute inside equals false, and then I guess we will return inside. Now let's get the first point, p1x. This is something like this. Corners at 0. Late. And then this loop here. So okay. So for I in, I guess what it's trying to do with the number of corners and stuff we can do with the range, I think. I'm not sure. Let's do in 0 to num vertices, or is it starting from yeah, so num vertices plus 1, and then this is the second point it wants to compare with. Okay, and then this logic here, this if condition, let's add a semicolon there, uncomment this, create that, p1 dot mean dot max p2y. Okay. If P1y is not equal to P2y, then too much nesting. And then this whole stuff right there. I guess we need to calculate this first, this stuff first. Y minus point y. And then here, outside of the outermost if condition, we need to make this mute and take so we take the first one, take the length, create this corners at first, range from 0 to +1. If get the second point, do this condition, they're not equal, calculate the intersection. If they are equal or less than the intersection not stated, call next. Cargo run. No, it returned false. And then let's check with another point where let's say 0. So this is the first row, the second row, the third row, the fourth. So 0, 4, right? So let's do 0, 4 is also not in that list, so let's do, but that's more complex, false. But 0, 4, 0, 1, 2, 3, 4 is not in there, but 0, 1, 2, 3, 4. 4, 4 is in there. So this should return true, cargo. Oh, it returned false. 4, 4 is not in there. 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. It's in there. But if we give it one of the corners, exactly one of the corners. So let's say 9, 5. Let's say 9, 5. It's still saying false. Maybe this thing always returns false. Let's say 0, 1, 2, 3, 4, 5. 0, 1, 2, 3. And let's do at the third column, at the third row, and the 9th column. It still returns false. Come on. think maybe there is a glam, or what was it? Rust glam, no, rust point in polygon. There are like some libraries for vector library, I guess. Vector library Rust. I forgot about what's there is some popular one they use with people use with Baby. Baby. Rust library with point in polygon function. The GeoCrate in Rust provides compressive geospatial primitives. Maybe this is what we should be using. Should we start? Should we try this? Cargo add geo. This is for like geospatial maths. Is it or is it for just for geometry? Okay. Then we need to, so in here I guess we need to create a date exterior no interior. Okay. Oh, this is actually, wow, this is actually a really powerful library. It lets you define that within them there might be even more empty spaces. But what we want to create is, I guess, an exterior. Because we only have the exterior. So let's say nodes cloned ether.cloned.map each position, so x comma y position, then create this chord from it, chord lsp start x as f64. What am I typing as? F64 and y as f64, and then this is from geocard, and let's say collect. What do we collect them into? A vec, I guess. So we have a list of coordinates now, and then we can say maybe this one has a distance, an area function we can use. Probably could have it. No, we're not gonna use that. Okay, exterior and exterior, let's exterior is going to be line string, a geo line string, which is gonna be from this exterior. And then we can create a polygon. So let's say like polygon equals geo.polygon.new, and then let's give it the exterior, and this can be an empty vec. So we have this polygon. Now we can say polygon that contains and then this has to be a point, I guess. Let's say point equals point geo point new, let's say 3,9 in this case. Let's say polygon that contains this point. It's giving us some errors, but let's see what they are. Oh, okay. I know what's wrong. We have to make this a float. It's still returning false. Come on, what the fuck? I guess it's a I have a wrong assumption maybe, because there's no way that this library is wrong, right? It's probably a famous library, let's say. Code rate or geometry, blah 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 blah. A bounded area represented by a line string exterior ring and 0 or more line string interior rings. A collection of polygons. A polygon. Is there a can I debug polygon? Can I do this? Wow, it returns a giant thingy. I don't know what's inside of it, but let's debug the exterior. Cargo run. What is this? Oh, all this time our previous algorithms might have been correct. Let's say let's go back to 3. Cargo run. Still false, but this is does it have display? Ah, I know what's wrong. So it's not closed. Our polygon is not closed, I think. So because what we have here is we go over all of them, but we're not connecting the last one with the. So it has. I think it expects the first and last elements. It expects the first and last elements you give it to be. I think in this, so close during, it says close during. So maybe what we need to do is exterior dot push, and then we can say geo chord, and then chord of x at the nodes at 0 dot 0 at f64 and y as f64. I think that's what it is. What if we don't do this, by the way? No, nodes. Will it complain? Nodes dot 0. That one. What if we don't do that? Let's move that. And then here we create a point with this. It works. You don't have to give it a. You don't have to give it a. What is it? It doesn't require floating point numbers. That's good. Let's try this custom implementation we have right there. Because 0, 1, 2, 3, and then at the ninth position, which is 0, 2, 3, 4, 5, 6, 7, 8, 9. So it's right in the middle of it. Let's debug is point in 3,9. Yes, the returns false. That's wrong. according to this, our first position is 7-1, so let's go rate 7-1, 11-1, 11-7, 9-7, and 7-1 at the end. Let's see if it contains one of the first. Let's see if this returns true. Let's say 7. No, let's remove that, and then let's say 7-1, because that's a point. That's a corner that returns 4th. What if we say 7-2? 7-8-1. How to check if a point is in a polygon using the geo library in Rust given a list of corners. Maybe they have a usage example of something in their repository. Let's see. Let's look for example. Centroid. Tell me I can do line string. I guess your polygon in order clockwise, not counterclockwise. How do this go? This go 7-11, 7-1, and then they go 11-1, and then they go 11-7, and then they go 9-7, they go 9-5, 2-5, and then they go from 9-5 they go okay, so 9-5. I guess this is not 0 1 2 3. This is not 9-5. So let's go over it again. This is at the so x and y. So we start at the 7. This is 0 1 2 3 4, 5, 6, 7. We start at 7, 1. There is no 7, 1. So this thing actually, maybe this thing is reversed. So this should be 1, 7. 0, 0, 1, 2, 3, 5, 6, 7. So they tricked us. So this is actually y comma x. It's at the first row and the 7th index, then the 11s, and then at the same row 11s, and then the same column here, and then here, and then here, and then here. This is the y, which is 7, and then it's 9, which is okay, and then we move up, we go to 9, 5, and then it goes to 2, 5 for some reason. 0, 2, oh, 0, 1, 2, 3, 5. Where is 2, 5? It's, yeah, 0, 1, 2, but 5, so it should be 9, 5, so it goes, and then it goes to the same column 3. I think it does look back around. Maybe we need to, it's saying clockwise or counterclockwise, it doesn't matter. And maybe we need to do something like +1 to all of them so that they are outside of their loop. This is very silly. I feel like why aren't our functions not working? Why aren't our functions working? I think this is true. Come on. We know that it contains 0, 1, 2, 3, and if this is 7, or 0, 1, 2, 3, 4, 5. So the 9's column, the 3rd row, should return true. Okay, I'm using an i64. Can I get a list of all the interior points? This will help us debug why it's failing. How long have we been streaming? 1 hour and 29 minutes. Keep puzzling. I'm gonna check on everything. Yeah, part one and so far gone all part two line now we got stuck. We got stuck in part two, even though we're using an external library to check. So what we need is currently an algorithm. So you get given, you have a list of corners, right? These corners. You have a list of these corners. So one, two, three. So a list of corners, and then we need a function that will check if that point is either in or on that um, that polygon. Okay, so let's say we also want the we want no we want is poly is in polygon function that will return true if the point is either inside the polygon or on the perimeter polygon. We've only been here for 1 hour and 30 minutes. ከሁለት ሰዓት በላይ አንቆይም። ከሁለት ሰዓት በላይ ከሆነ we are gonna get out of here. Oh, what the heck? But okay, so that's a polygon. Maybe let's get this giant function. But if we're gonna have to write this giant function, it's not really helping us. The library is not really helping us do anything in that case. If we still have to write this giant. If we have created our So it's saying 2,8 is part of the is inside the polygon, which is 2,8 means the second row, 0 1 2, and then here. Okay, it is in that case it's true then, and then the second one is 2 9 2 10, so it is actually doing it. But let's go to 9. I guess this should have been 3 9 in my case. And then Carboron. And okay. In that case, let's actually, maybe this thing is working all along. Has been working all along. Okay. So what we need to do is we have our polygon. We want to do this, we want to do that, but here we're gonna need to do wait a minute, wait a minute, wait a minute. Oh, I removed the tuple here. Tuple combinations. So what we need to do is okay, so we need to come up with a fancier new distance function here. So it has the points, but now it needs to calculate all of the positions. So so top left top left is gonna be x1 comma y1. All right, and then let top. So we need to make this, let's say, let's do this. So this is the width. Let width equals that, and then let height equals that. Okay, And what we need to do is top left, top right is going to be x1 y1 plus width, right? And then it's a bottom right is x2 comma y2, and then the bottom left is going to be x2 comma y2, but in this case it's y2 minus width, I think so, and this could end up being negative, or I guess it will end up at 0 0 or something, or it will overflow and we'll get an error which is gonna be annoying. I think it will overflow and potentially return an error. I guess we can instead calculate it via a plus. So bottom right is that, and then bottom left is going to be so x1, so bottom right is plus 1, and then from this bottom left is plus 8. So instead of that we can say it's y1 plus 8, because if we do minuses it could get mixed up. So we will return an option, so distance is gonna now be an option instead, and if all of this if is in polygon for all of them, we will also need the polygon here. In that case, polygon, which is that if polygon, and I guess this all of them are points, so let's say geo point new on all of this, geo point new, and then I guess we will also need to do something like this. A no, we don't have to do that. We just have to dereference them at a bunch of places. So let's say x, and then select y. So is in polygon top left, and is in polygon top right, and is in polygon bottom left, and is in polygon bottom right. So if all of these are true, we want to return some width times height. Otherwise, let's return nothing. And then here we can flat map. Okay, it's returning some error here. Oh, in that case we can just do this then. Okay, if there is some distance, let's do a comma b comma distance, otherwise let's do none. I mean, no, okay, let's do a reference to the polygon. This is actually not distance but area. Expected one argument, found 3. Okay, of course. Let's just see what the largest distance was. 24. Let's, instead of logging that, let's list all of the debug distances. So it was 5, 2 and 3, 7, but it should have been 5, 9 and 2, 3. Why is that? Is it because debug is in polygon? Point 3, 2. So 3, 2 is in there. What about 5, 9? Both of them are in there, but their distance didn't turn out to be so it chose. Which one did it choose? So 5, 2 means 2, 5. 2, 5 is 0, 1, 2, and then 5. Where is it? 0, 1, 2. I don't even think this is correct. So guys, we is the switcher row I'm doing here correct? In our list we're receiving a what is it? Let's see. Okay, it's saying, for example, in here it's between 9.5 and 2.3. So this is at the third. So this is saying it's the third column, which is 0, 1, 2, 3. Zero, 1, 2, 3, and in the second column. So 3 is the y value. So how much? 0, 1, 2, 3, y, and then 2 is the x position. How much we should go to the left or to the right? So according to this would be, so that the two most, like the largest area, that is the biggest area we're getting now is, in this case it's at 5,2 to 3,7, but so this means it's from 2,5 to 7,3. I don't even think we have a debug nodes. There's the 5,2. Where is it? So this means it's at the fifth column. The fifth what? I think I'm messing that up. Let's revert it. X position, Y position. 0, 1, 2, 3, 4, 5, and 2, and then 7, 3, 0, 1, 2, 3, and then 7. That's not correct, because the two ending positions need to be on the boundary, but no. In our condition, I think our condition is stricter than we want it to be, or it's not specifying it enough. But I don't think so. It's the x, y, run. This point is 15 now. So let's undo that. I think now it's correct, because they're giving us the row and then the column. So this one, for example, is saying it's at the second. So 2, 3, 0, 1, 2, 0, 0, 2, 3, which is 0. No, this is already correct. We don't have to do the inversion. They're already giving us x and y values, so I can't go wrong. Ba-bam. 11,1295. 0, 1, 2, 3, 4, 5. No. It means, so this is 11,1. So that's at the first row. And then so this means this is at the fifth row. So 0, 1, 2, 3, 4, 5. And then 5,9. So this is the ninth position, I think. 0, 1, 0, 1, 2, 3, 8, 7, 8, 9. So it's saying this is the largest one. Our new distance calculator is saying this is the largest one I can find. Maybe we don't need to add the plus ones now. I'm not sure. 12. But the points, okay, they differ a little bit. I think we need those because, yeah, we need the widths. So why is this invalid according to our rules? Or why didn't it find one? Why didn't it find the other biggest one? So we are requiring it to be is in polygon. If the poly contains it or if it's on the boundary. So top left and top right. No, top left and bottom left. Bottom right. So these are the original points. These are the points that we want. These are the OGs. So top right, and then will be at the same X position, but we just need to add the width to the this is incorrect, because if we are at X comma Y here, and then this point, if we have width here, this is gonna be X plus W comma Y. And then if we have an H here, and then this is X plus W plus Y plus H. If we go left here, or if we go down, this is at the same X, but it's Y plus H. So, and then bottom left is X1, the same X position as the top one, and then Y1 plus H, or I guess plus H. Ugh. I think this is correct. Now we're even getting less distance. These points. I mean, but this is correct, right? So we're given two positions. We're gonna assume so bottom right is x2 comma y2. So this is x2 comma y2. This is x1 comma y1. We know the width by doing x2 minus x1. Just remove this. I'm not sure about this plus one. I don't know. 8. Sure about that. and then we don't need to check if the top left and the bottom right is in the polygon, because we already know that. We want to only check the top right and the bottom left corners, I think. Yeah, so that didn't change anything because we already know that we are there in the polygon. That's just duplicated work. Because if both of them are in the polygon, like for this one, that's the case for, I think, this one. Oh. Oh, but the corner still have to be. Yeah, so in this one, it's this corner and that corner. And then here, I guess, let's do a Cartesian product with nodes dot iterator, because maybe it matters which side we're going at it. No, it's the same distance, 7173 and then 7173, but the same distance, so it's not the Cartesian product, the tuple combination. How long have we been here? We've been here for 2 hours and 9 minutes. Okay. Yeah, I'm not gonna do more than, I said I'm not gonna do more than 2 hours today, so let's just do this. Just ask, is there a bug in this? We are trying to calculate the largest area contained within the polygon given all the corners polygon, the largest possible polygon. Only the top left and bottom right corners have to be at the vertices of the polygon, but all the corners of the rectangle we Okay. Oh, 14. It got the correct number, but the width and height is incorrect because this should be. Okay, so I think what ChatGPT said was we're just assuming x1, y1 to be the top left corner, but now it's now calculating, sorting them. So if x1 is less than, yeah, if x1 is less than x2, if x1 is less than x2, which means x1 is more to the left of it, so which means that makes x1 the left corner. And then basically it's just calculating them based on, so that's the left corner x2. If x1 is, yeah, if okay, then x1 is the left corner, and in the right corner is r2, if that's the case. Okay, I think that's correct. You find all corners is pointing polygon, and now we can print back the solution. I guess I'll back print solution is gonna be distances at 0 comma, no, distances at 0 at index 2. I think I'm still offline. Oh, it's saying no data here. OBS crashed maybe, but it's now saying excellent connection. OBS crashed maybe, but it's now saying excellent connection. Okay, OBS crashed maybe. I think it's working. So we have this new distance, or I don't know what to call this. It should be area. So we now have this new area function, and it gave us this number, and I only noticed that I was not, so my internet got disconnected when I was trying to submit this. So it's trying to submit it. It's not the right answer. God damn it. Yeah, part 2 is tough. So basically what we have here is, let me delete this. Yeah, so the area would be less than that. That's correct, I agree with that. And then we choose, so we go over each combination of tuple combination of like a comma b's, and then in the area we first decide which one is the leftmost one, which one is the rightmost one, which one is the topmost one, and stuff like that. And we create these new points because we're using a library called Geo to calculate if the point we're gonna be considering is inside the polygon, and then we iterate over all of them to check if they are actually in the polygon. We do the is in polygon checks on them, and then once we have the width and height, we add +1 to it and then multiply it to get the final width. And then this works for the example. So it's like If we run it with the example, we get 24, which is correct. 24, but it's not working for me for the actual inputs. But yeah, maybe I'm just gonna commit this. Commit implement die working with example. At least we did part 1, so maybe I'll do part 2 later today, but I have to go now. I think yeah, let's do that. Let's see what we committed. Push it. Yeah, so at least we got part 1, so let's go. I think there is a simpler algorithm to check if they are in the to check if a point is within these coordinates. Maybe I will find the solution for that somewhere, but yeah, I think yeah, that's it for today. See you tomorrow. Goodbye everyone. I think I've been here 2 hours and 30 minutes, so goodbye.